In this video, I'm going to show you how to do a synthesis problem using the routine OscerSyn. Now, OscerSyn is a graphics program which is all about synthesis. It's all about predicting reactions, carrying out reactions in sequence to lead to some intended target molecule. Now, the way we do these synthesis problems, it's a bit of a game. We set up an arbitrary rule. We want you to come up with a sequence of reactions which will give the target molecule, in this case this ketone, and what you have to do is you have to start with compounds which have 4 or fewer carbons. Now that's an arbitrary rule that we do just for the purposes of the quiz, because in the actual chemical laboratory you would start with whether starting materials give you the that you have and that give you the best path to the product. But we're going to play the game. Now, how do we go about this? Well, you have to do it by analyzing your molecule and thinking backwards. Now, in this particular case, we have a ketone. Now, what did we learn about ketones? Well, we learned but ketones, of course, can be made by oxidizing alcohols. There's other ways as well, but that's by far the most common way it's been done. So most likely, this ketone would have come from an alcohol. Now, that's really, really good, because when we talked about making carbon-carbon bonds, our most common method for making carbon-carbon bonds was to start with a lithium reagent or a Grignard reagent and react either one of those two with either a aldehyde or a ketone, a carbonyl, or you could use them to open an epoxide. Both of those reactions would give you an alcohol. The alcohol could then be oxidized to a ketone. So that's the way to think about this problem. Think about this ketone came from an alcohol, and the alcohol was made by using one of our carbon-carbon bond forming reactions using, let's say, a lithium reagent. So how do we get to this ketone from an alcohol? Well, we did it by an oxidation. What's the reagent? Well, the reagent, if you remember, was this chromium compound we call PCC. Now, how do we specify this? There's no text box up here. Well, the reagents you get from the reagent list. And if you look through here, there's all sorts of reagents, and every one of these reagents is used somewhere in the full year-long course of organic chemistry. But we're talking about reviews, so we're just going to use a few of these. And here's our PCC. This is our chromium reagent, which allows us to oxidize an alcohol. So I'm going to draw in the reagent, but I still need the main reactant. And of course, the main reactant is going to be the same compound, but before it's oxidized, so it's the alcohol. So I'm going to duplicate the molecule using the 1 to 2 button, then drag this over here, and I'll change that double bond back into a single bond. So there's our alcohol. Now we can check to see whether we're right by going up here and say use the Evaluate Reactions button. And if we click that, it says OK, we know we've done the reaction correctly. So now we have to make our alcohol. Now an alcohol, simplest way here is to react a lithium reagent with a aldehyde, and we can do this 2 different ways, because we can either break the left-hand side of the molecule or we can break the right-hand side of the molecule. Let's arbitrarily say we're going to do the left-hand side of the molecule. So what do we need? We have to count our carbons. 1, 2, 3 carbons on the left. That means we need a propyl lithium compound, and then 3 carbons including what's going to be the carbonyl. There's 3 carbons on this fragment, so that's all 3. So that's the aldehyde, the 3-carbon aldehyde, propylaldehyde. So let me just move this a little bit up to the corner to get just a little bit more room. So I'm going to draw in my reaction arrow, okay, and I need the 3-carbon aldehyde. So let's draw the aldehyde first. And so here's our aldehyde and 3 carbons. So there's our 3-carbon aldehyde. And then I need my 3-carbon lithium reagent. So 1, 2, 3, and here's lithium. Put that over the arrow. Now, if I push the button right now and let that work, what's it going to do? It's going to give me an error. Let me see, I'm going to show you. It's going to give me an error. See, error. Why is it an error? Because when you react that lithium reagent with the carbonyl, you don't actually make the alcohol, you make the alkoxide, the anion of the alcohol. So all we have to do is throw in some acid to make this work. So throwing in acid means we do an acid workup. This means in the laboratory, after you did this reaction, in your flask you would have the the alkoxide, and you throw in some acid to what we say work it up and isolate your intended product. So what this simply means, acid workup means after the reaction is finished, we throw in acid. So I just put this in down here, and now if I push the button, it'll say OK. And it does, so we kind of know what we're doing. Now, you could do the same reaction on the other side. You take ethyl lithium and you take the 4-carbon aldehyde. That would work as well. How else could you do it? Well, you could have an epoxide. You could have a 4-carbon compound here with an epoxide there and open up that epoxide using ethyl lithium. So there's various strategies, but this is a simple one and it works. So let's be happy that we got it to work. So we need to save our answer. Okay, we need to close Oscar Sketch, and then we can submit answer, and we submit our answer. It says indeed we were correct. So we got the first one right. So there are 10 problems for you to work on. Good luck with it, and have some fun reviewing how to do synthesis.